developed in Pupuk Indonesia Group. Yeah, the use case is anomaly detection for plant reliability in Pupuk Indonesia Group. And first of all, allow me to introduce myself. My name is Domi Aswiandi. I'm working as a project manager of data science team in Pupuk Indonesia. For those of you who haven't heard about Pupuk Indonesia, let me introduce our company. Pupuk Indonesia has 10 subsidiaries across various industries, mainly fertilizer industry, but we also have subsidiaries that working on other industries like EPC, trading, logistic, energy, and food. But in this use case, in this session, we will talk mainly about the left side of the screen. These 5 companies, Petrokimia Gresik, Pupuk Ujang, Pupuk Kalimantan Timur, Pupuk Iskandar Muda, and Pupuk Sriwijaya. The use case will focus on this fertilizer manufacturer. Yeah, a little bit of background. Pupuk Indonesia is a global industry leader in fertilizer industry. So we sit in 6th position for total asset, revenue, and net profit in the last year, financial year 2023, compared to our peer in the same industry. In total, our production capacity for fertilizer products around 14.6 million tons per year. It consists of some of the different products like urea, NPK, superphosphate, ZA and ZK. And then we also produce non-fertilizer products like ammonia, phosphoric acid, and sulfuric acid with a total capacity of 8.6 million tons per year. It is produced in 5 different subsidiaries, like I mentioned earlier. So one of the some of the biggest challenges that we face today to maintain our production level are plant reliability and IT/OT integration. So our company operation is highly dependent on the plant reliability because our main product, fertilizer, is produced by these 5 subsidiaries. Some of the problems that we face today are sometimes we cannot detect symptoms of a problem that potentially will lead to an unscheduled shutdown. So this unscheduled shutdown is very costly for us because we can lose the sales opportunity, and also it will incur a quite high cost to start up the factory and to start the production again. So it's very critical for us to maintain the plant reliability. And also the second challenge is IT/OT integration, because the holding company Pupuk Indonesia was established after the 5 subsidiaries. So when we were established, our 5 subsidiaries already has operational technology in place with the various technology, various licensor, and also various standards. So we need to integrate all of these different technology into our IT and data infrastructure. So that's the challenge that we face. Now we will talk about the anomaly alert system that our company developed in partnership with SLB. I will try to simplify the data flow. I will not talk too much detail about the technical side, but this will give you enough idea how we develop the system. We collect the data from 5 different subsidiaries, and then the data itself is sensor data, process data from the factory floor. It is collected into a RDBMS system like MySQL and SQL Server, and then after that we ingested all of this data using Airbyte into a Snowflake data cloud for the ease of access. So after we got all the data inside Snowflake, the model development is developed within Dataiku. Why we use Dataiku? Because it is recommended by SLB as our partner. They have the domain knowledge about factory, manufacturing industry, and also Dataiku is a low-code and no-code platform. So it is easier for us to develop the use cases there because we can use some of the built-in feature and technology that already there. And then why we choose Snowflake for this use case? There are a lot of benefits that Snowflake can offers. But I think the main reason that why we choose Snowflake because of in this use case particularly because of its integration options. Snowflake can be easily integrated with a lot of platforms. Almost all of the major platforms out there can be integrated using Snowflake. Like in our cases, we integrated it with our data visualization tool like Tableau, and then also machine learning platform like Dataiku and Nine. Apart from that, Snowflake also give us scalability, collaboration, ease of use and maintenance, and so on for any other use cases that we develop. Yeah, as you know, Snowflake has released Snowflake Cortex just recently with anomaly detection model as a built-in model out of the box. Yeah, we can already try it right now. But when we first developed this use case, it hasn't been released, so we choose the other path using Dataiku. But I think in the future, we will consider to explore this option with Snowflake Cortex to improve our model. This is the workflow, the overview of the workflow that we follow through. First, the data we collect all the data from our digital fertilizer system from 2017 to 2023, all of the sensor data and then also historical shutdown data. And then we do the data pre-processing to get the normal data set and separate it from the anomaly data set. And for the classification model, we use residual-based model to label the data into normal or anomaly. The first step is data gathering and validation. So like I mentioned earlier, we use 6 years data, and then we collect it into the Dataiku platform and combine all of this data into one data set for us to process in the next step. So it consists of a lot of data, almost near real-time data. The frequency is 1 minute for each data point. For all of the sensor, we have tens of sensors. I think more than 30 something. The sensor that we collect. And then the next step is we do the exploratory data analysis. As you can see here in the screen, blue box here means that we take out some of this data inside the blue box because it is irrelevant and noisy. I think this data is interpolating the real data from the sensor reading, so we need to take care of it. We need to eliminate this data to get the normal data. And then after we removing this data that we deem irrelevant and noisy, we do some resampling because the size of the data is quite huge from 6 years of operations. So we resampling the data to make it more efficient. The process can be much more faster and efficient in terms of computing process. And then we also omit the data before 2019 because of its quality. Because when 2018, we just started the piloting process, so the data is not quite good at the moment. That's why we just use 2019 onwards. And then after that, we do the data labeling. We label the data into two categories. First is normal, and then the second is anomaly, based on the training, based on the domain knowledge of us and SLB, and also based on the statistical information that we calculate from the data itself. So as you can see here, the blue box represent the normal data, and then outside of the box, it is the anomaly data or the data that irrelevant to the training data set. So for the model, the development of the model, we adopt the normal behavior model, or also known as residual based model. So the idea is how we can calculate the difference between output channel from the sensor and then prediction channel from the ML models. We compare these two values and then we calculate the difference. The difference is called residual value. And then we set the threshold, this red line. When the residual values below the threshold, we call it normal operation. And if the residual value above the red line, we call it the anomaly data. So this anomaly data is what we want to detect earlier. Based on our discussion with SLB, NBM can be applied to various complex systems such as compressor, turbines, process equipment, and ESP. We compare this model also with other models. So we have three different models. First, residual-based model, and then we also have anomaly detection model using isolation forest, and then also we have remaining useful life-based model. So after we compare these three models, we found out that residual-based model works best for this particular use case, because I think in our case we don't have many samples anomaly and also shutdown data. We have a lot of samples for normal operation, but for the anomaly and shutdown, we don't have much data to be the reference point. That's why a residual-based model works best. But I think in another scenario, we can use other models that might be work better. This is the dashboard for the anomaly alert system. So this web app will be facing the customer side. After we develop the model inside Data IQ, and then we put the model to inside the model Snowflake, and we set the prediction task there. And then we expose the data using Fast API and Python as a backend system. Then the front end, we develop a custom web app to show the plan status in near real time based on the certain range of value. So we set a minimum and maximum range. So if the data outside this range, it will alert the operators that the plan is in anomaly state, and then we send the alert into WhatsApp. This is the sample of WhatsApp notification received by the plan operator. If the system detects that it has an anomaly, it will send it to the operator that the anomaly occurred in certain dates and certain time, and then it will show which sensor or which tag number that has a potential problem, so that the operator can anticipate the potential disruption of an operation. So see, this is the basic, the main idea is how the operator can prepare and anticipate for the upcoming potential disruption of the plant. Okay, to sum up my session, I think there are several key takeaways that we can get. First of all is Uh, like uh, like I said earlier, Snowflake can be easily integrated with variety of platform. One of them is Data IQ, and in our internal data stack, we also have different platforms like Tableau, Nine, Airbyte, and also we have data governance tools and machine learning operation tools that can be easily integrated with Snowflake. And then the second point is, in many cases, the use of no-code platform like Data IQ can speed up the development process. In our cases, we can speed up the time more than 50%. So from around 4 months to 2 months. So I think that's a good result after we try the low-code and no-code ML platform. Then the last one is the release of Snowflake Cortex potential will make the development process even faster and easier. Yeah, I think we in the next phase we will try to explore and evaluate the Snowflake Cortex anomaly detection model out of the box, and when we will compare with our current approach, I think it can significantly simplify and make it faster and easier for the development. Okay, I think that's all that I can say in this session. Thank you for your attention and see you in the next event.
Thank you so much,
Hand back to you.
Tommy.